Hey 8th grade, this is Ms. Harkness, and this video, while called 7.1, is an introduction to Eureka's Module 7 content of rational and irrational numbers. If you were to look at this actual Eureka lesson, it touches on the Pythagorean theorem, which is something we are going to teach later in Module 5. So for this video, while it's called 7.1, it is an introduction to Module 7. And in this video, I'm going to show you how to classify numbers as rational or irrational. So with these two types of numbers, you can pretty much classify any number within these two categories. Now, when you get to upper level math, obviously there's more beyond what we are learning in 8th grade. But for today, for this video, we are going to focus on rational and irrational numbers. You'll notice within the word is this word ratio, right? So it's either rational or it is irrational. It's one or the other. It cannot be both. So let's look at the definition of these two numbers. By definition, a rational number is a number that can be made by dividing two integers. So for example, it can be written as a fraction. So some examples of rational numbers would be things like 7 or 1/2 or 6.2, because that would become 6 and 2/10, which would become 6 and 1/5, which would become 31/5. So you can see that while it's a decimal, it can be written as a ratio. However, an irrational number is a number that cannot be expressed as a ratio. So if you were to write it with a decimal notation, an irrational number would have an infinite number of digits without repetition. Something like root 4, if you type that in your calculator, it's going to equal 2, right? 2 times 2 is 4. But if you were to type in root 5, you're going to get 2 point something, 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 something. Not a repeating number. So that word repetition, I'm going to highlight it. That is what matters the most. Non-perfect squares, which we'll get into in lesson 2, are examples like 5. They are always, literally always irrational. Always. Non-perfect squares are always irrational. There's no exceptions to this. You'll see that we will turn root 5 into a decimal number. We are allowed to round it and truncate it, cut it down to a more manageable number. But as it stands, root 5 is an irrational number. Also, something that is always going to be irrational is a number that has pi in it, because pi is irrational. So something like 6 pi, 4 pi, 99 pi, all going to be irrational numbers. Hope this video gave you an introduction to what rational and irrational numbers are and are not.